Yeah, regarding method of analysis, it is exactly the same as we did in timber and concrete. We use elastic analysis, but with factored loads. So we factor the loads here, as you see, but we use elastic method of analysis to get the shear force diagram, bending moment diagram, and so on. Then we check for ultimate limit state. What do you mean by ultimate limit state? You should ensure that MR is more than MF. VR is more than VF. Otherwise, you increase the section size. Then you check for serviceability. You would like to check for deflection. In timber, we say that we check for deflection due to dead load and live load with a span over 180 as a limit, or a span over 360 for live load only for a floor, or a span over 240 in case of a roof due to snow load. In case of steel, maybe next time we will talk about that in a way that we will camber the beam upwards, so we'll bring the beam like this. In the fabrication shop, we will bend it upward like this with the amount of dead load. Then you bring it over the columns, so it should appear like that. But after you put all the dead loads and so on, it will become horizontal like this because the dead load deflection will counteract the camber. So in this case, any additional load will create that deflection. So this is a deflection due to live loads that you need to check. So this is the reason in the structure drawings we specify the amount of camber to the beam so that the steel fabricator can bend the beam this way in the fabrication shop. Okay? And we check by calculations only for live load.